Hello everyone, welcome to our today's live sky observation session. Today we along with our education team are ready to show you Mars. You can also see it on naked sky, new sky. It's quite bright to see it on naked sky. Now what you're watching is our telescopic view, quite zoomed. You can see the red planet. Okay, I'm waiting. Let's see when people are joining. Just enjoy the marvelous view of Mars. Okay, we are adjusting our telescope. It's out of our view now. Okay, now it's back again. We are moving in the telescope to keep up with the Mars. Okay, we are adjusting the telescope and it's back on the screen. Okay, you can see at the center of your screen the red planet Mars. Mars has average temperature of minus 81 degree Fahrenheit, or in Celsius it's minus 63 degree, which is quite cold compared to our Earth. And its atmosphere is also quite different from our Earth. Whereas in our atmosphere on Earth, we can find several kinds of gases, but in case of Mars, its atmosphere is mainly made of carbon dioxide. Actually, primarily it's only carbon dioxide. About 96% of Mars atmosphere is composed of carbon dioxide. And also there are some other gases found in minor amounts, such as the argon, nitrogen, but they are very little in amount compared to the carbon dioxide. And another interesting thing is that the atmosphere of Mars is very thin. Um, but the atmospheric pressure, it's on the surface of Mars, it's quite different from Earth's. Now we know that Earth has one of its own satellite, that is Moon. Mars has two moons, and Mars gravity is also different from that on Earth. Like the gravity of Mars is actually 62.5% less than that on Earth. So if your weight on Earth is, let's say, 100 pound, then on Mars it should be just 38 pound. But remember, I'm talking about the weight but not the mass. So your weight, which is the mass times the gravity, that will be 62.5% less on Mars because of the gravity. And the length of the orbit is also different from the Earth, because it's also further from the Sun, and the length of the year on Mars is about twice than that on Earth. In our case, the Earth takes 365 days to revolve around Sun, whereas in case of Mars it needs 687 days, so which is almost twice as long as on Earth. And if you talk about the volume of the Mars, then you can actually fit more than 6 Mars inside one Earth. So its size is just 1/6 of Earth's size. Now, as I was talking about its atmosphere is quite thin, and that generates many interests in the astronomers. They want to know why the atmosphere of Mars is so thin. Uh, that's not like what's on Earth. Also, the atmospheric pressure at the surface of Mars is only about 0.6% of Earth's. Now, you can think what can happen if there is so much low atmospheric pressure. I'm pretty sure that many of you may have watched the movie Martian, where a man was actually he had to live and survive on the surface of Mars. Now, if I tell you that suppose you are a Martian, and suppose by any chance you have been given an opportunity to live on Mars, which I guess we are all excited about right now, then what could be the possible challenges that you will immediately face, and what will be your first step when you will start living on the Mars? So let's start from very basic, like you will need food, so you will have to cook. So just think about it. If the atmospheric pressure on the surface of Mars is just 0.6% of Earth's, so think very basic questions. Can you boil the water there, which is the first thing that we will need to cook? I can give you some hints, like what happens when you go to Himalaya or such greater heights above the sea level. You know that the atmospheric pressure changes with altitude, and there is some rate. Okay, we have tried to zoom the planet, and you can see the zoomed view of the planet, and you can clearly see the patches on the surface of Mars. Now, let's back to what I was talking about, the atmospheric pressure change with height and altitude. Now, you know how it changes. So let's just go back to your calculation and see how much it changes with the height. Um, so I can give you one problem that will be quite interesting, I think. Just go back after the session and find out the minimum atmospheric pressure that you will find on the Earth. The minimum atmospheric pressure, like where is possible? You can go to the highest height. Okay, I'm back again. Sorry for the interruption. So, what do you think? Where can you find the minimum atmospheric pressure on the Earth? Of course, on the maximum height. So, for an example, let's take the height of the Mount Everest and then calculate the decrease of pressure there. So, you can actually calculate how much is the decrease in percentage. Just try to calculate it compared to the atmospheric pressure on equator and then on the Mount Everest, and then see how much is the decrease in atmospheric pressure in percentage. Now remind yourself that atmospheric pressure on Mars is 0.6% of Earth's. So you can imagine then what is going to happen with that low atmospheric pressure. Now the scientists are doing their research because they think that the Mars may have had a thicker atmosphere in past actually, and then probably it has lost some significant amounts of its atmosphere through time. Actually, NASA spacecraft is indicating that kind of research, and they are blaming sun for it. According to their research, they assumes that probably it's because of the solar wind that the Mars atmosphere got a great loss. That's why it's now thin. We already know that there are many missions ongoing for Mars, and they have different objectives. And the most discussed one is from the NASA spacecraft. We all know that people are trying hard to find life on Mars. Also, we are looking forward if they find it. So, we know that initially it started with seeking water on Earth, because for like Earth, if there is any living being on Mars, then there should be water somewhere in liquid state. So scientists try to find out liquid water on the surface or anywhere on Mars. That could be an indication that there could be some living being, some habitant on Mars. But now they have just changed their strategy. Now they are trying to find out some fossils that could be preserved from early, that could tell us that life once flourished on this planet. So now they are looking for evidence of cells that can be preserved in rocks or at some smaller scales. We call those kind of fossils as molecular fossils, because they are at very much smaller scales, and they are called biosignatures also. So the NASA spacecraft is right now looking for some fossils, maybe some molecular fossils, biosignatures, and some specific compounds that can give indication of organism that created them. But there are also some difficulties, like those molecular fossils are lying there for hundreds of millions of years. So there is chance of those fossils being destroyed, or they could have been transformed to the point where we can no longer recognize those as biosignatures. So those possibilities, challenges are already there, and that's why scientists are finding it hard to find any signature on Mars. So they have separated their goals in some parts. First of all, the main goal that also we are also looking forward, that whether Mars have ever supported life. Now, one thing that we can think, that why we are looking for life on Mars and we are not interested on other planets just like the Mars. The Mars is right now the center of interest because the Mars and Earth, they both have some relatively similar worlds, like their early histories, and the life arose relatively early on the Earth. So it is possible that maybe the life was also evolved on Mars in past, but that's the key question. So they have divided their goal in actually two objectives. First of all, they are trying to determine environments that could have a high potential for prior habitability and some preservation of biosignatures that will contain evidence of past life. And the second goal, they were looking for expression of those biosignatures that contains evidence of extant life but on current times. So both the past and the current life, both kind of signatures sorry, are what they are looking for. Thus, the strategy has changed because we have now gained more knowledge about Mars. So they no more seek water, but they look for signs of life. Also, it's very important, as I was saying, that the atmosphere is quite different on Mars. So they are trying to understand the process and history of climate on Mars. The fundamental question is how the climate of Mars has evolved over time as it has reached the current states. The processes that were responsible to produce this evolution. That's an important topic of research, and whether the Martian atmosphere, those climate, it actually reflect an universal feature. That means you can expect this kind of planetary atmosphere in other planets as well, whether it is universal or not. So if it is universal, then studying the atmosphere on the Mars will help us understand the atmosphere on other planets as well. And compared to that, it's easier to seek here because it's closer. So they are trying to characterize the climates of the Mars actually in three time scale: on present, on recent past, and in the far past. So if you can characterize the state, the history, and its evolution of the climate, then probably you can understand the underlying process. But it's about hundreds of millions of years, so it's really difficult to get to any conclusion now. Another thing is to understand the origin and evolution of the Mars as a geological system. So, the NASA spacecraft is seeking insight into the composition, like the structure and also the history of Mars as a planet. And for that, it have to have a deeper understanding of its surface and interior. That's why it's trying to collect those samples, different images from its surface, so that it can investigate in lab. And it is also a compelling scientific exploration in its own right. Um, but they are quite hopeful that maybe the planet also might have once hosted some living being. So what they are trying to do is that, first of all, they are trying to document the geologic record and interpret the process, and then they are trying to determine the structure, composition, its evolution of the interior especially, and how it has evolved. And then it's trying to determine the manifestations of Mars evolution as recorded by its moons. Finally, uh, as we are all waiting for that day, that if we can prepare it for human exploration. So maybe in future there will be one day when robotic flight missions will prepare for potential crewed missions to the Mars systems, and maybe we will go to visit the Mars. Probably one day there will be such kind of time. So in this case, they are trying to obtain some knowledge of Mars. If it's sufficient to design and implement the human mission to Mars orbit. Of course, we have to keep in mind the acceptable cost, risk, and the performance. And also, they are um, trying to get the good knowledge on its surface of either Phobos or Deimos, that's its current missions. Now, if I ask you, do you know which country made it first to Mars? No, it's not NASA, but it's Roscosmos. It's a Russian space agency. They were the first one to make it successfully to Mars. They launched their Mars 1 in 1962, which was an automatic interplanetary spacecraft, and it had an orbiter as well as a lander. Now, those this Mars 1 was intended to fly by the planet at a distance of about 11,000 kilometer, and it was intended to take images of the surface, and then it will send the data on several things like cosmic radiation, micrometeoroid impacts, and Mars magnetic field, another important thing, radiation environment, the atmospheric structure, and possible organic compounds. And I'll tell you, the main two challenges, among many challenges, the main two challenges of such mission is, one is the orbiter, whether it can successfully orbit around the planet, I mean, whether it can successfully move around the orbit, and the second thing is for the lander, whether it can land on the surface. Mars 1 did not successfully landed on the surface. It was just a successful, a partial success orbiter. Then it tried another mission, Mars 2, which also failed. Then finally in 1971, so after 9 years, it's Mars 3. Mars 3 sent a lander on Mars, and then it sent a signal. It landed on the surface, it sent a signal, but only for 14 seconds. So it was a partial success, but still we could say that okay, it landed on the Mars surface. Now, it's not only that the NASA and Russia and also Europe is on the list, but our India is also in the list of Mars mission. And you may have heard about the Mars Orbiter mission, or in short MOM. It's also called Mangalyaan. It is a space probe that is orbiting Mars even now, since 24th September 2014. It was launched by ISRO on 5th November 2013. So it's still orbiting. So we are also in the list, and we are also looking at Mars like the other countries. Okay, now we are going to show another facility at our NEHRU Science Center. Okay, and people who have already visited Nehru Science Center, you may have gone to Science on a Sphere. Okay, we are going to give you a view of science on a sphere. There we will show you a very zoom view of Mars. Actually, there you can see exactly the structure on the Mars surface. It's a really a great view. If you have never been to science on a sphere in our center, then of course do visit whenever you come next time to visit our center. Ensure that you buy tickets for the science on a sphere, and then see those marvelous view. Okay, we will just show our science on a sphere program just for the Mars. You will get an idea how it looks. Okay, till then just enjoy the telescope live views. And don't forget to solve the problem that I gave you. You can write your answers in the comments, maybe in 2 days. Discuss with your friends, anyone who you like to discuss, and then just come back to the comment section, give me your answer. I will definitely check them maybe after 2 days. So keep it as a homework. I think it will be interesting for you to know as well. And also let us know how are you going to survive on Mars if you are given a chance. That will be exciting for you. Okay, just wait. When we are trying to load our video on the Science Sphere, stay connected, and there are also some more announcements. Okay, we are adjusting it to fit our screen. Okay, sorry for taking this long. Thank you for staying connected. This is the view that you will usually see when you will come to Science on a Sphere. You can see the Mars surface. It's a marvelous view where you can see each and every details.
Hello everyone. You can see this. This is not live program that we are showing here. This particularly talking about Mars. This is one of our facility called as Science on Sphere, wherein you can see the great cannoli, and then that Olympus Mons also can be seen here, the tallest peak in the solar system. And apart from that, you can see that this planet is called as red planet, and there are some very dark patches. So it is the very high percentage of iron oxide is present on Martian soil, and it is because of that you can see this surface as a rusty surface, and those dark patches, here the iron oxide percentage is much more. Even there are some similarities between Earth and Mars, And the most important thing is the axial tilt. The axial tilt of earth, you all know that it is 23.5 degree, whereas the axial tilt of Mars is 25 degree and 19 minutes. So it is because of this axial tilt we can see various seasons on Mars, just like we experience seasons on earth. So during different times we can see different uh, hue on Mars, different colors of Mars. So can you all see that that great cannoli can be seen? Now we are seeing here that Olympus Mons. This is the tallest crater, tallest mountain, and this is 3 times taller than Mount Everest, which is there on Earth. The height of Mount Everest is around, say, 9,000 meters, whereas the height of this Olympus Mons peak is around 27,000 meters. So it is 3 times higher than Mount Everest. So these are some very prominent features of Martian surface that we are seeing here. Uh, these are the recorded images of the program that we organize in our Science on Sphere program. You can see the other part of Mars here, wherein to the left corner you can see the left hand side, you can see this Valles Marineris, and see the again this is the longest canyon on in the solar system, with length of 400 kilometers. It is 400 kilometers long, say around 200 kilometers wide, and 7 kilometers deep. So again, a very prominent feature of Mars. And when Mars was volcanically active, when it evolved in the solar system at that time, all these features they formed. But now Martian surface is not volcanically active. Basically, this Valles Marineris, this feature, it created because of the plate tectonics in the during the initial stages of or initial form of Mars. So these features can be seen here. And you see, just as this is moving, as it is rotating, can you see these 3 mountains just besides this Valles Marineris? Basically, this is Tharsia region, plain on Martian surface. And see, the peculiar part is you can see that those 3 mountains, they're equidistant to each other, and collectively this region is called as Tharsia. And you can again see that just besides that Olympus Mons also can be seen. So in this single picture we can see all those features. Here again, this Olympus Mons can be seen very prominently. Over to you, ma'am.
Yes, yes.
Yeah.
Okay, I'm back. I hope you have learned many things about Mars. Many of you wanted a closer view. I hope now you are satisfied with those views, and you will get more information on other planets as well, and many more things in our Science on a Sphere session. It's quite informative, and also it's quite good view actually to your eyes. It's quite soothing because you will get to see those planets in a bigger size at the center of the room, and you will see every details on its surface. And along with that, there will be a commentary with many more informations that will be helpful to know for the kids and as well as any student. Now our live session is coming to at an end, but don't go now. There are more to announce. Well, many of you know about the events, the rare event that's going to happen on 21st December, and we are also planning to do a live on the Saturn and Jupiter conjunction that's going to happen on 21st December. Now, I don't know how many of you have heard about the conjunction of Jupiter and Saturn that's going to happen on 21st December, but for those I'm going to explain, just giving some introduction. Usually the astronomers use the word conjunction to describe the meeting of planets or any other objects in our sky's dome. And just remember that they are although moving in different orbits, but what we see actually, it's from our own perspective that we see them as overlapping on each other. So it's our from our point of view, and it's going to happen in on 21st December. It's a great conjunction, and we will also do a live session on that evening. And before that, we are planning to meet sometimes on the next week, maybe it will be good, and that will be actually a preparatory stage. I mean, we will try to hold kind of a workshop what you can do for that view, I mean for the angle measurement as well. And we're trying to plan that maybe in the next week. So keep following our Facebook page where you will get all this information about the upcoming programs. And okay, just keep following, we will hold it, and there I will explain in the conjunction more. And just remember why the event on 21st December is so important. Actually, I'm just giving a brief detail. Every year the Saturn completes about 12 degrees of its orbit around the sun, while the Jupiter completes only 30 degrees. So you see there is a gap of 18 degrees, so 30 minus 12. So the Jupiter closes the gap between the two by about 18 degrees. So in 1 year it's 18 degree, which means in 2 years the gap will be 36 degree. So in 10 years it will be 180 degree, just opposite to each other. And what about after 20 years? So if you multiply 18 with 20, so it will be 360 degree, which means almost it will be similar to as 0 degree, we know. That's why after after every 20 years, the Jupiter and the Saturn, they come to overlap. um, you can imagine, if this is happening in 2020, what was the last conjunction that happened? It was 20 years earlier in 2000. And why it is important? Because the closest Jupiter Saturn conjunction happened 400 years ago. It was in 1623. That was a time just 14 years after Galileo made his first telescope. But that was not clearly visible because it was very close to the sun, just 13 degrees east of the sun. That's why many people could not observe it. We assume that. And now we are getting the chance again on 2020. and the similar actually conjunction will happen in 2080. So if you miss the event on 21st December, then you will have to wait till March 15, 2080. So mark your calendars, stay connected with us for the event on 21st December. But before that, we will meet again, maybe sometimes in the next week. So how do you feel then? Till then, you can watch them naked sky. They are already there in the sky. So just go see how the gap between Jupiter and Saturn changes day by day, and it will start just visible. From 17, so from 17 to 25th, you will see how they are coming very close. So enjoy the view. I hope you have liked our live sessions. So like, share our videos, and obviously follow us for the upcoming programs. Thank you.